This is a rebroadcast of the Healthcare Engineers Association of Southern New Jersey meeting held on Wednesday, March 10th. Today, we have AJ Patel presenting epoxies and hospital maintenance, helping you manage unique challenges every day. AJ Patel is a mechanical engineer with nearly 20 years of experience in multiple industries, including facilities engineering. He is currently the business development manager for both Repair Technology and Banks Industrial Group, and has over a decade of experience working with epoxies to help customers overcome challenges within their facilities. I will hand it over to AJ to discuss epoxies.
Awesome. Good. I guess it's afternoon right now. Good afternoon, everybody. I appreciate you taking the time to watch this video. Arya, wonderful introduction as always. So as Arya mentioned, I have a little bit of a background with epoxies. I have over 20 years of experience in multiple industries, including facilities management. So I thought it would be a real good idea to start. Let's talk a little bit about what an epoxy is, right? Because it can mean so many things to so many different people. And the fact is that really understanding, how you see it and then really what it is, it's a good way to have the conversation. So first, for a lot of folks out there, you walk into the garage and they've got that beautiful floor. Well, that's an epoxy flooring system. Anybody who's got a tile floor in their home, that's also an epoxy. Coatings on the inside of equipment or coatings on pumps, that's an epoxy. Some people see epoxies in those applications. And finally, the granddaddy of them all, go down to Home Depot, go down to Lowe's, go down to Ace, whichever one's your poison there, and picking up a pack of that JB Weld. JB Weld is probably one of the more popular epoxies out there, and what most people see when they see an epoxy. But this presentation, I want to kind of adjust your bearings here. An epoxy is really three parts combined into one, and that is a resin, a solidifier, and finally a filler system. And you put those three together, and that's how you have an epoxy. And the type of filler that you have really drives the type of properties that you're going to get out of that epoxy, and thus the applications that you can use it for. So first, thermoplastics. Anywhere you may have a thermoplastic filler, you're going to have more flexible, more rubber-like applications, more rubber-like epoxies. When we talk about aggregates, stone aggregates, well, that's cement, that's concrete. You're going to see more of those properties. Metals, you're going to find, yes, I'm being dead serious. Metals, if you combine epoxies with some of the metal systems that are out there, you actually can repair metal with an epoxy. You can machine it down and it's as good as new. Do that a lot. We're going to cover that a little bit later. Finally, ceramics. Ceramics help give an epoxy a hard face. So if you've got things flying and they hit it, guess what? It helps create sustainable, long-lasting finishes. So why are we talking about epoxies today? Why was I asked to come and have this conversation? And that is because in my career, my experience, there's a new challenge to be faced every day. Every day is different, and speaking to folks, they love going to work every day. Why? Because they see something different every day. And so you're going to face new challenges every single day. And guess what? The epoxy is a tool in your toolbox. It's something that you can use to help you be successful every day at what you do. And so our goal today is to help you understand when an epoxy is the appropriate solution for you and your organization to overcome challenges. And so what are some of the benefits? What are the things that you need to think about? Well, are you in an environment where you kind of got to see a reduction in downtime? You've got to see equipment repaired fast and put right back into service. Epoxies are a great application for that. Portable and storable. This is huge. So epoxies, the ones that we're going to talk about today, they actually were developed on offshore oil rigs, right? So how amazing is that? We're going from the oil industry offshore. Now we're talking about hospitals, which are clearly onshore. And so why is that important to know? Well, when you're on an oil rig and you're 15, 20 miles offshore and equipment fails, you can't just go down to the local shop and say, hey, why don't you machine me a new part? Or why don't you repair this piece of equipment? you can't call up Granger and be like, hey, can you send me, some of the things that I need? It's not possible because you're 10, 15 miles offshore. And that requires helicopters and logistics and a lot of money. So epoxies really did a great job of growing up there, because with epoxies, it's, Play-Doh, think Play-Doh a little bit. You can kind of shape them the way you want, depending upon the filler material to give you the properties you need. So they're easy to store away. They're very portable. You can ship them in bulk. Now, they provide protection from common sources of degradation. So we're talking about erosion, corrosion, abrasion, chemical attacks. These are the types of things where epoxies will absolutely perform well for your organization. So today we're going to talk about some common healthcare maintenance challenges, and you've got a few. So the first one, leaking pipes. Now, obviously, this particular leaking pipe, this is something you're going to see in your bathroom, under the sink. That's not what we're talking about. We're talking about the bigger carbon steel piping situations. Concrete failures and floor coatings. So concrete fails. It's going to fail over time. You understand the freeze thaw, you understand the cracking. We're going to get a little bit more into that. But the fact of the matter remains is that hospitals have a lot of concrete. They have a lot of concrete, and we're seeing them fail, and we're going to have a good conversation about that today. Now, expansion joints. Every time I've gone into a hospital, anytime I talk to a facilities manager or a hospital, I say, hey, what keeps you up at night? What are the things you're thinking about? Expansion joints. We talk a lot about expansion joints. There's a really unique solution out there utilizing epoxies to help you with expansion joints. We're going to talk about today. I think you're going to enjoy it. And finally, failing and inefficient HVAC systems. Yes, the heart and soul of the distribution of air and air quality inside of your hospital buildings. That is a place that there could be a lot of help. There could be a lot of help to help you solve them problems. So let's first start off with the leaking pipes. Let's talk about them. Here's 3 examples. There's many more. I'm not going to read them to you, but here's the bottom line when it comes to leaking pipes. They're a huge impact, because once you get that water coming out of that pipe, right? Even if it's a little leak, it doesn't have to be a big leak, it could be a little leak. A little leak is still water. And if that water gets somewhere where you have organic material and it's cold, guess what? You're going to experience a situation where now you're exposing your facility to mold, mildew, and you're going to potentially have a shutdown. And guess what happens? That's going to impact your indoor air quality. And we all know how important indoor air quality is when we talk about the health and safety of our facilities. Sewage leaks. So this is on the back end of your system. Look, here's the thing about sewage. Sewage is nasty, nasty, nasty stuff. It tears up pumps, it tears up pipes, it tears up equipment. And the fact is you're going to need a solution to help you repair that equipment, get it back in service. So what can be done? Composite wrap systems. Utilizing epoxies, a composite wrap system can solve a lot of your problems when it comes to leaking pipes. So what is a composite wrap? Well, let's talk about its purpose. First, the purpose of a composite wrap is to restore the strength of a pipe. Okay. So when you have a pipe, it has a thickness to it. That thickness has a certain strength to it. When you put it together, it's called hoop stress, right? Can't, something's in it, it's pressuring out. You got hoop stress. The fact is that when it starts to degrade away, you've got less strength in that radial direction like that, and it could fail, right? So the composite wrap will actually rebuild the strength on the outside of that. It's pretty cool. So what is it made of? It's made of a binder or a filler, right? That's actually the epoxy, right? A reinforcement material, and you add those two together, you get a great composite wrap. And, for binders, we always recommend epoxies. You could use polyurethanes. Here's the issue with polyurethanes. They're very expensive, and they're also activated with water. And the fact is that when you have those two things, you've got a lot of cost associated with it. When you compare that to the strength, the adhesion, and the chemical resistance of the epoxy is the way you're going to want to go. Sorry about that. What sort of reinforcement material can you use? Fiberglass, carbon fiber, age-old debate. Fiberglass, very flexible, very easy to work with. When we say wetting out, we're talking about working with, and it's got really good strength. Carbon fiber is so strong. It is one of the strongest materials on the planet. Very strong, but very rigid, not very flexible. It's hard to work with. It makes it very hard to work with, but man, so strong. So we recommend a hybrid solution for that. If you're going to utilize a wrap system, find something that's a fiberglass carbon fiber hybrid. And really, when you talk about repairing leaks, when you look at this situation right here, and I'll bust out the telestrator, you look right there, and what you're going to see is you're going to see an active leak. When pipes are actively leaking, it's hard to shut them down when they're attached to a piece of equipment, for example, like a cooling tower. Not easy to shut them down unless you have really good redundancy. But here's the problem. Let's say you do, and you go to shut the valve, those valves don't always close. I've been around hundreds, maybe thousands of valves. It's actually thousands of valves in my career. They don't all shut, right? So you may have to deal with a level of a leaking pipe no matter what you do. Well, the fact is that a wrap system, when you have an experienced technician, they can actually wrap over that leak that you're seeing right there. And the end result is a fully reconstructed pipe from the outside that isn't going to be leaking and allows your facility to continue to operate. So with that said, I'm going to go ahead and I'm going to play this wonderful video that we have here of the composite wrap in our shop. We're actually, we're going to demonstrate how you would actually use it and how your team would go from there. Well, I hope you enjoyed that video of our composite wraps of a composite wraps solution. And we're going to jump right into concrete repair solutions. I think you're going to enjoy this section. So let's start off with something that I've seen in every hospital, which is a loading dock. Some of them have loading dock ramps like this. This particular loading dock ramp actually was repaired several years ago. I went back recently. I'm going to tell you about that. But look, I have seen this time and time again. Somebody out there, I don't know what time period, it was definitely before me. I don't know that I would do this, but people are doing this. Somebody decided that the best way to repair failing concrete is with diamond plate steel. I don't know who thought that was a good idea. But look, when you do that, look what happens. Bust out the telestrator again. Look at all these areas where this concrete is breaking apart. It doesn't look good. These are problematic areas. And the problem is that as the concrete starts to fail, it ends up getting beat up and you're ending up having to shut down and interrupt what you're doing every day. Well, here was the problem with this particular challenge is that this ramp couldn't be shut down. In order for the facility to operate, it actually needed to be running constantly. So the window for shutdown was maybe a 12-hour shift, not 3-4 weeks, which is what it takes for concrete to cure. So the application that was utilized was epoxies that have that aggregate in there that make them more like concrete. So what happened here was the ramp was the metal was removed and then a ramp was installed. And what happened was in this section down here, where I'm going to circle, a rebate was cut. And when that rebate was cut, it allowed the epoxy to feather down to 0. So it was feathered down to a 0. And when it was feathered down to 0, it made it nice and smooth, tied right in with the existing concrete. We put, some nice safety yellow in there. Great work. Good looking ramp. And, I was actually there just a few months ago. Still looked as good as new. Dock leveler systems. This is huge. Pay attention. So in the dock leveler systems, diamond plate was installed. Now, here's the problem. there's a huge misconception with diamond plate. The conception is that diamond plate is really good for non-slip. Well, that's not correct. In fact, the purpose of the diamond plate is to more easily slide things across it. By raising those bumps, you're reducing the surface area. Well, a coefficient of friction times the surface area gives you how much friction you have. So if you have less, if you're going to reduce the surface area, guess what? You're going to reduce the amount of friction. So that's the purpose of the diamond plate. So what's happening is we get this call a lot is areas where it's kind of put in as a non-slip, these dock levelers, water comes in, ice comes in, snows comes in, people are standing on it, they could get hurt, right? So what happens is that companies are, they come to us, whether it's in a hospital, whether it's in any type of building that has these, and they're like, hey, we need to have a solution here. Well, if you look closely, what is done is that an epoxy system is actually put in. The surface is prepped, an epoxy system is put in, and then an aggregate is put on top of it. So if you look closely, you could see here's all the bumps, but there's a lot of bumps in the bumps. That's a lot more surface area compared to what you're seeing on this side, right? So what happens is now you increase the amount of friction. People aren't slip, trips, and falls. Safety is number one, always the most important thing. Safety is always the most important thing. And you put that nice, bright, beautiful safety yellow on there. You can't miss it. You can't go wrong. So this is a similar application. This was for anti-slip purposes. And in this case, what it was that you have these two, okay? So these two vats, this isn't a hospital. I'll admit that. It's not a hospital. These two vats have granular structures in them that are used in the pharmaceutical industry. But here's the catch. They're perfect balls. They're like ball bearings. They're perfect balls. And they're tiny. So what happens is when they get dumped out, if any of them get on this very smooth concrete, guess what? It's like stepping on ball bearings on smooth concrete. It's very, very bad. It's not very safe at all. So the same approach was used. The floor was prepared, an epoxy was put down, an aggregate thrown in the epoxy, and then that beautiful safety yellow put on there. Now, a anti-slip situation has been created, much safer work environment for the workers there. Now, here come the docks. Okay, every hospital I go to has this situation with the docks. The docks are beat up. You've got inspectors coming in from the state. They're looking for everything. The fact of the matter is they may see your dock first, depending on which entrance they come in. Now, look, it stands to reason that the reason that these docks are failing, because what happens is as the trucks start coming back, right? As the trucks start coming back, here's what happens. They come back slowly and then they hit the bumper, right? But here's the problem. Momentum is mass and velocity. So you can go very slow. If there's a lot of weight in that truck, even if it's going slow and it hits that bumper, there's a lot of energy moving. There's a lot of energy. And that's why these loading docks get so destroyed, because the trucks, as slow as they might go, every time they touch them, they're transferring a ton of energy into that wall and it's falling apart. Well, here's the crazy thing about concrete. You can't fix concrete with concrete. In fact, one of our top customers for epoxies is actually a concrete plant. They make concrete. And every year they have a shutdown, we go in and we fix their concrete. Why? Because you can't fix concrete with concrete, especially in the vertical direction. We're going to talk a little bit about that more in just a second. But if you take a look here, see how this was beat up? We got the telestrator out, nice and beat up. You can look down here. Wow. Like brand new, nice, clean, clear, crisp. State inspector is going to come in. They're going to look at that and they're going to say, these guys got their act together. Steps. Let's talk about fixing concrete in the vertical and the horizontal. Okay. So some time ago, I know these steps really well. My wife actually delivered her son at this hospital. I've been up and down these steps before. I'm very grateful those lights are no longer there. Now, some time ago, somebody decided we're going to put lights and steps for ambiance. Well, it's not a good idea, because whenever it rains, you get a freeze thaw, the light breaks up, and boom, guess what? They don't work as nice anymore. So then what ends up happening is they become an eyesore, and then people look at that, they see that, and then it says something about your facility. You don't want that. You want a great facility. So in this case, those lights were cut out. You could see that here, cut right out. And then an epoxy system was actually used to repair in the vertical and the horizontal. Can't do that with concrete. No shot at doing that with concrete. And then we turn around and guess what? We were able to, you turn around, you put an epoxy coating on the top of it, nice, durable. It'll last a long time. See these, just was at a hospital a couple of weeks ago. Helipad repairs actually came up as a topic of conversation. And these get beat up for the exact same reasons your loading dock. Look, helicopter comes in nice and smooth, right? But any little amount of velocity it's going to hit with those helicopters, they're not feathers. They're pretty heavy, right? So when they're heavy like that, they're going to hit that concrete and they're going to break up the concrete. And guess what? You're going to have to repair it. So rather than cutting out sections of the helipad, pouring in the concrete, waiting for it to set, painting over, you're going to just keep doing that endlessly. Use an epoxy. An epoxy, you can go right over, smooth it over. It'll fill in the epoxy. Here's an interesting tidbit. Compressive strength of concrete after you let it sit, perfect conditions, all that, you're looking at about 8,000 PSI. Epoxies within 24 hours will be between 12 and 14,000 PSI. So within 12 to 24 hours, you're going to have a better compressive strength, a stronger material, and you're going to have it up and running. So in this case, went in, filled in all the holes, leveled it all out, put a nice epoxy coating across the whole top thing. Beautiful hospital H right there in the middle of that beautiful cross. And now that helicopter can not only see where it's going to land, but it's going to continue to do so. And we're going to that's going to turn around pretty quick for you. Parking garage repairs. After this winter, every parking garage you walk through them, it's like walking through a rainforest, right? There's just water dripping everywhere. It's dripping. Why is it dripping? Because when you have a winter like what we did, where you have freeze thaw, so much of that ice got into the concrete itself. It freezes, and then when it freezes, it expands, it breaks up the concrete, it thaws out, and water drips through. It creates crack systems, and all those systems, everything is moving through it. So every time it rains, you're going to see water just pouring through in your garages. So what do? How can you fix that? You can't use concrete. Like I talked about, you can't use concrete because you can't use concrete to fix concrete. Use an epoxy. You can go in, you can seal up all that concrete utilizing epoxy systems. Parking garage expansion joints. This is a huge topic. This is very important. Pay attention. So here's the deal. When it comes to epoxies are 2 parts and a filler. None of those components has water in it or has a solvent in it. Okay. That means nothing is evaporating off. So when you use an epoxy system for your expansion joints in your garage, when you put them in, not only do they bond really well with the concrete, they don't shrink. They don't shrink at all. And because they don't shrink, guess what? You're not going to get any cracking. You're not going to get any of that crazy stuff that happens to the expansion joints when you use normal caulking systems. Floor coatings, finally. Now, I've seen this a million times. Somebody somewhere thought big concrete barriers that should be stopping cars. Somebody thought that that's a really good idea to stop chemicals. It's not a good idea. Concrete is very, very, very porous. When the chemical hits the concrete, it's going to go through the concrete. You can see here these 2 vessels. Sodium, I believe it's sodium hypochloride. And in this case, or sodium hydroxide, in this case, what happens is that it hits the floor, it goes to the drain, right? But in the meantime, it's tearing up all of that concrete. So what do? You go in, you use an epoxy system, you coat that floor, you make it beautiful. Anything leaks out, guess what? You're not going to have any problems. Elevator basins. This is huge. Your elevators are anchored in these basins. And guess what else is in there? Hydraulic fluid, all kinds of other fluids that could get out. They could start tearing up the actual concrete itself. And if they tear up the concrete, guess what's going to happen? You're going to compromise your elevator system. So here's what you're going to do. Put an epoxy system in place. You utilize an epoxy floor coating system. You put it in there. Anything that leaks out, guess what? Hits the epoxy, gives you a chance to clean it up. Your elevators are now nice and safe. All right, let's talk about failing expansion joints. I talked about this earlier. I mentioned that we're going to have an entire section on this. And there's a really good reason why. Every time I go to a hospital, this is a huge topic of conversation. And why is it a huge topic of conversation? Because, you're a big building and you have expansion joints and you need them to operate correctly. Because if they don't operate correctly, you're going to have other problems in your facility. So here's the most important thing to understand about expansion joints. They allow your building to move. And why do you want your building to move? Well, because the earth moves. And because the earth moves, the ground moves. And because the ground moves, the building moves. And because the building moves, guess what? The floor should move. And if everything's moving and you're picking up these little vibrations, guess what? Everything's fine. If you start locking buildings in place and not allowing for that change, you're going to start cracking your floors in all kinds of different places. So an expansion joint is built-in movement. They're designed to allow your building to move, and by allowing it to move, you actually increase its reliability. Here's the problem. The current application, the current approach to expansion joints involves metal, rubber, concrete, and VCT tile. Okay, that's 4 components. 4 components. Now, when something moves, everything moves and stretches at different rates. Temperatures change, everything expands and contracts at a different rate. Well, guess what? If you've got that many components that are moving, it's a recipe for disaster. So that's number one, recipe for disaster. Okay, number two, they are ugly. They are ugly. I have never went by an expansion joint, except for the one I'm going to show you in just a second, and thought, oh, that's a good looking expansion joint. They are ugly. And the reason why they are ugly is because ultimately they're big hunks of metal sitting in the middle of your beautiful hospital, and they make a lot of noise. And finally, look at the tile around it. You look at this tile, that does not look like good tile. That tile's getting beat up. You can see it over here. And you know what? Oh, we'll just replace the tile. Well, eventually you're not going to have the same lot, and you're going to have a line of tile next to your expansion joint. It's always going to look different. So these expansion joints are an issue. And I've seen a lot of different approaches to fixing them. The most popular one right now seems to be taking very wide pieces of stainless steel, ripping out basically from one VCT tile all the way to the other, taking that entire section out, and then laying that stainless steel down and then anchoring it down. The problem with that, if you're doing that, stop doing that. It's a bad idea. It's a really bad idea, because now you're anchoring your building to itself. That's very bad. You can't do that. It's going to cause bigger problems for you. Here's what we found beneath these joints. This is even worse. We have found dirt, debris. We found needles. They're damp. They're dark. We found cigarette butts underneath there. I mean, think how old some of these joints must be if we're finding cigarette butts, right? When's the last time anybody had a cigarette in a hospital? And all of these conditions ultimately lead to mold. And when you have mold, you now have indoor air quality issues. These expansion joints are absolutely necessary, but the current way in which they're being solved and being handled is not in alignment with what you're trying to do in your hospital. So it's old technology versus new technology. That's how you have to look at it. This is an evolution. This is a step that has to be taken as we as a society learn a little bit more about how we can make things better, right? So that's how you have to approach and look at this. When you look at the old expansion joint technology, right, you see that, look, you've got somebody that's going to be mopping your floors every night. Well, when they go mopping their floors, guess what? You've got these metal joints and they're going to have little gaps in there. And you know what? That water is going to end up on the inside. And it's going to end up on the inside with a whole bunch of dirt, a whole bunch of debris. It's going to be dark. You're going to get mold. You're going to get mildew. You're going to have indoor air quality issues because of it. Yes, I said it. Expansion joints are a cause of indoor air quality issues. The other thing, look at this tile. It's going to look ugly, and you know you're getting those inspections done by the state, and you would much rather have something that, you know, looks and is 100% sealed. So what do? Use an epoxy. This is called a smooth ride system. This particular epoxy system, here's what's done. We talked about before, you rebuild the concrete itself, right? Doesn't always have to work that way in every situation, but you know, you rebuild the concrete, and then you put a nice coating layer on the top of that, a nice wear layer. And then in between them, remember I said, you can use thermoplastics and get something that's more like an elastomer. I said that at the very beginning. You put that in between the two sides. Here's the deal. This expansion joint, listen carefully, this expansion joint will move with your building. No problem. But it is also 100% sealed. There is no gaps. There's no way for water to work its way in. It sits right up against the VCT tile, nice and smooth. And it is beautiful looking. Look how pretty that is. That is a good looking expansion joint. If that is in your hospital administrators are going to be really happy. Your hospital visitors are going to be really happy. And your inspectors are going to be very happy. This is absolutely the way you want to attack your expansion joints in your hospitals moving forward. Here's the great part. Expansion joints aren't always just one straight line. They're not 1 8-foot length. They actually are varying lengths. They could be in different shapes and different sizes, different geometries. This one's kind of got like that. It's like a hockey stick, right? So this one's more like a hockey stick. How about this geometry? Look, geometries, architecture is not simplifying. It is getting more and more fancy. We're trying new different things, new shapes. Hospitals are trying to look distinct. This is a way for a hospital to be able to keep up with the times and be distinct and be reliable. So the benefits, first and foremost, the safety, the air quality issue. This is so important for your hospitals to really be thinking about. You don't want people slip, trip, falling. You don't want people getting any kind of mold or mildew or anything like that. These are one and done solutions. We have epoxy solutions that have been in place 10 to 15 years already, and they will continue to operate. They've only been in place for 10 to 15 years because that's how long they've been installed for. When we hit 20 years, I'll be telling you they've been 20 years. When we hit 30 years, it'll be 30 years. These things will last. The turnaround time is fast. You're talking about single trade coordination. One person, one trade can come in, knock out the joint and leave. So that makes a lot easier for you as the facilities manager to come in and do your job. So fast turnaround time, we can get them in. They can get in and out in 24 hours. Variable geometries are not a problem. It's a completely sealed solution. And look, compared to the stainless steel itself is extremely expensive. Then consider coordinating the multiple trades. You will find that these solutions are extremely cost effective when you consider everything you're actually paying for when you put in a traditional metal joint. So I'm going to play a video for you right here, a little bit of background. I think you'll enjoy it about expansion joints in action.
It's not often that one considers the inner workings of buildings we frequent. An important feature of building architecture is the expansion joint, which allows natural building movement. This mid-structure separation, conventionally covered by a metal plate, is commonly known by their disruptive sound. These metal coverings tend to have an impact on medical equipment and patient transportation. Though conventional metal joint covers bridge the gap, after regular cleaning and maintenance, one can only ask, what lies beneath? Gaps in mechanical covers create an opportunity for mold and microbial growth. Underneath these covers, we've found dirt, needles, and even cigarette butts. Improve safety with our Smooth Ride solution. This flexible elastomer application effectively seals off expansion joints while still allowing natural building movement. Let's see the Smooth Ride application in action. Improve safety in your facility with this durable long-term solution.
All right. I hope you enjoyed that video. Give you a little insight. Those joints look great, don't they? I think you really got to take a look at them. So finally, let's talk about HVAC systems. HVAC systems are the heart and soul of your air distribution inside of your facility. And they have really three main parts: your condenser water system, chilled water system, and then finally your air handlers and your duct work. The condenser water takes water and cools it way down. The chilled water system, that's where you exchange with refrigerant. Refrigerant sent over to the air handler where the air blows in one side and blows out the other side, and it goes from hot to cold, right? And that's the direction. So that's what the air handler does. Now, here's what can happen in your HVAC system. You can have a lot of erosion and corrosion that can happen, and we're going to talk about where it would come from. But ultimately, when you have erosion and corrosion in your HVAC system, it leads to lots of problems. So first, reduced operating efficiency. When you have corroded equipment, you don't get as good a heat exchange. when you have leaks in your equipment, you don't get as good a heat exchange. Okay. Energy has a harder time. It takes a lot more for it to transfer. It takes longer. That's inefficiency. And when you have inefficiency, that means your equipment isn't capable of meeting the goals that you set for it. The goals in this case being the temperature. So guess what? It's got to run longer. And when it runs longer, that means you're increasing the operating cost. Okay. So now we've increased the operating cost and we're running it longer. So this equipment is only designed to run for so long. And because you're now running it longer every day, you're starting to shorten its overall life. So now you're running it longer, you're spending more to run it, and you're shortening its life. And guess what? This is expensive stuff to replace. HVAC systems are not simply and obviously you know this, but to a lot of people, they're just simply the thermostat on the wall. No, they're much more than that. They're big pieces of equipment, and they require legitimate time to maintain. And so this is a huge issue when it comes to erosion corrosion. And finally, but actually the most important, safety and indoor air quality. If something goes wrong in your HVAC system, the problem is that it's going to end up everywhere. Once you have a problem in your HVAC system, you have a problem everywhere. So what are common issues when it comes to the cooling tower circuits? Well, one, the pipework. We talked about this earlier with the composite wrap systems. Once you start seeing failures like this, you put yourself in a position where you've got to kind of get those fixed right away. Secondly, your basin and your sidewall collection areas. So this is really important because when a basin, what happens that, they can be made of a polymer, they could be made of a metal, but they always have pipes to them. There's always other equipment in there. It get exposed to the water. There's oxygen. You get rust. Things start to corrode away. You start to see failure. So some of the common issues, some of the common things that we'll do is go in and actually start sealing up your cooling tower basin on several fronts. And when you seal it up, what it does is it prevents water from getting out. If the water starts getting out, then you don't have enough water to do your heat exchange. And then you see that, hey, first you get the inefficiency, then you're spending more money, then you're shortening your life, then you're replacing the equipment, right? It's all a downward spiral from there. The other thing is if the water gets out, it's got to go somewhere. And if it starts making its way into your building, you're going to have a problem. Now, leading edge corrosion on the fan of a cooling water tower. This is something that people don't think about too much, but when you see a cooling water tower, and it's very evident in the wintertime because you can see the actual droplets in the mist, coming out of the top of these stacks, you see a lot of water vapor, and that's the warm vapor that's actually getting sucked out so that the water stays as cool as possible. Well, those fans are spinning. And what happens is that the front edge is a profile, right? It's like an aerodynamic profile. And over time, guess what? All that water, it starts destroying that, and they call it the leading edge. And once you start destroying the leading edge, now you're going to be more flat. You're not going to be aerodynamic. You're going to be flat. And guess what? As it's moving through the air and it's getting hit by these droplets, a lot more wind resistance. So in order to maintain its speed, guess what? The motor has to work harder. That means you're going to spend more money. You spend more money. You get the whole idea. This is how this becomes a downward spiral. So what can be done? Well, what is done is you rebuild that leading edge and you rebuild it with epoxy systems. Now, here's what's really great, because these epoxy systems, essentially, remember I talked about earlier, you can put something with like a ceramic type filler in there. Guess what? You make it nice and hard. How much do you think that leading edge is gonna get beat up now? I mean, it's gonna get beat up, but it's gonna last you a lot longer. You're gonna increase the lifetime of that just by utilizing an epoxy system, A, to rebuild the leading edge of that blade, but B, to then put an overcoat on there. Pump shaft. I just saw a really, really neat example. I was at a job walk, and in this case, it wasn't a pump shaft. It was actually an HVAC air handling shaft, and there was a motor at the end. And what happened was, this was about 15 foot wide. So the air handler was about 15 foot wide, but when we went in there, you turn on the motor, it started shaking a lot, right? So your pump shaft was beat up really bad. They had to put a new collar on there. But you got to fix that pump shaft. If you don't fix both and there's not a snug fit, you're going to have a problem. Well, here's the issue. On each side of the air handler, there's only like 5 feet of room. Well, you can't get 15 foot to fit in 5 feet. I don't care what you do, you can't do it. So what can you do? You have to repair it in place. So this is a great application for epoxy systems, because the epoxy can be molded like it is here to the outside diameter of the shaft itself. You can get a mold, put it right over there. You have the epoxy in there, and within hours you take off the mold and boom, right there, Your shaft is now ready to go. You fit it in back where, you know, whether it's a seal or whether it's a collar, you put it back in place and you're good to go pretty quickly. All right, so let's talk a little bit about galvanic corrosion. Why does galvanic corrosion happen on a chiller system? Well, it's very simple. You've got two metals and they're not the same metal. They're dissimilar metals, right? So you have the carbon steel tube sheet, which is the gray area, and you have the copper alloy tubes, which is the yellow area. And so this is where you're going to have your potential issues when it comes to galvanic corrosion. So first, it's important to understand the construction here. Okay, so the way that these chillers are assembled are these alloy tubes actually slide into this stainless steel tube sheet, and when it slides in there, what happens is on the inside where they slide into, there's actually a tool that gets put in there. It's called a roller, and it actually expands the copper and then it's rolled in. So you get a completely tight seal. So all of this, like you look here, these are all rolled in place. There's no welding that's done to any of it. And so what happens is you have a roll that exists basically right in these areas right here. Well, pay attention to what happens next. Now, all of a sudden, you have dissimilar metals, so you get corrosion. Boom, there it starts corroding away even more. So see where my lines, where I made those lines? Well, that's where your seal was. You don't have a seal anymore. So now anything that's on this side is going to move over there, and anything that's on this side is going to cross over here. And when you have that kind of crossover, that's where you get your inefficiency loss. When you get your inefficiency loss, your equipment has to run longer. When it has to run longer, you have to spend more money. And when it runs longer, guess what? You also reduce the overall operating life of the equipment itself. And now that's a huge capital cost. So what can be done? These systems can be repaired. You can see it right here. It's the same exchanger faces in the last picture. And in this case, what's happening is that the exchanger face is actually being steamed out. It's being cleaned off. Once it's cleaned, that metal, remember I talked about earlier, the fillers. So in this case, we're going to use the metal filler. We'd use the metal filler to rebuild that face. We'd actually put every one of these holes, there'd be a cork put in every one of these holes, right? You'd have corks all throughout this whole thing. So you'd put corks throughout all the holes, and then what you'd do is you'd fill it with the metal. You'd fill it with the epoxy metal. And when you fill it with the epoxy metal, then what you do is, remember I talked about the ceramic coating. Now you put the ceramic coating on top of the metal coating, and guess what? You're going to extend the life of that exchanger. That's going to last. That's a good chiller. That chiller is going to last a long time. Air handling units. These are huge. Air handling units really focused on the ductwork itself. This is huge because this is your indoor air quality system. You have a problem here, you have a problem everywhere because all the ductwork goes to one centralized location and then spreads out to everywhere else. So in this case, where we see the biggest problem is the insulation. You go in, I have seen insulation, if it's a year old, it's already destroyed. Why? Because you put the insulation on and then it starts getting a little crack. The water gets in there, it starts getting soaked up. Then you get winter and you get freeze thaw, it breaks up the insulation. Guess what? You're going to have problems. The problem is it makes its way to the ductwork. And I know stainless steel ductwork, all that. But guess what? That's still going to end up rotting through. I've seen it a million times, right? So now you're going to start seeing corrosion in the various areas underneath the insulation. Then it's going to hit the ductwork itself. You're going to start seeing failures in the joints and the ductwork. You're going to see holes. Now you've got water in your duct system where it is damp, and oftentimes it can be cold. And you've got insulation, which is rotting away. And that's a great place. That's organic material. That's a great place. Mold, mildew, all of these problems that we know, and these are indoor air quality problems. So what can be done? Epoxies can be used to completely seal the HVAC ductwork itself. And if you completely seal it, you're not going to have those problems. Now, look, a lot of this ductwork can be so far beyond repair that you're going to actually need to go in and maybe replace it with ductwork, but they have sealed ductwork solutions that you should look at as well. And we could talk about that more. Just give us a call. I'm going to go ahead and play a video now. This is just an example of some failed ductwork insulation. This is actually only like 3-4 years old. Watch what happens when they start ripping off this insulation. You actually will see water coming off of the insulation. Well, I hope you got something out of that video. I appreciate the time you took to meet with us today. My name is AJ Patel, Business Development Manager with Banks Industrial Group Repair Technology. My phone number, my contact information are listed below. I want to just take a moment to thank everybody for watching this video, having me on to give this webinar. I really appreciate the time. All right, everybody. Have a wonderful, wonderful day. Take care.